right, so today we have Stefania Druga. She is an independent researcher, most recently a research scientist at Google DeepMind, where she worked on multimodal AI applications. So Stefania, welcome to the podcast.
Thank you. Thanks for having me.
So you've had actually a very interesting journey. So you've built AI education tools for young people, I guess even all the way up to 7-year-olds. And then afterwards, you worked on cutting edge multimodal AI at DeepMind. So, what have kids taught you about AI design? I guess that most of us AI engineers miss.
I think kids teach us a lot of things in general, but in particular about AI design. I mean, it's been quite a journey. I started working on AI education in 2015, and I was part of a Scratch team at Media Lab at the time, and start building the first AI education platform for kids called Cognimates. So kids could train their custom models with images and text, and then use those custom models in their own projects, like in visual programming language. And yeah, they would do things I never thought of or adults never think of, like build a model to identify weird hairlines, right? Like with pictures of people that have like very weird hairlines. Or for the text models, they wanted a model that can recognize and give you backhanded compliments. And all sorts of things that are weird and quirky and fun and not necessarily utilitarian in nature. I think when we talk about large language models and AI today is very much like from this utilitarian perspective, or how it can automate part of our work, or how it can make our work faster. But young people don't have that approach, right? Like for them, like driving a car is far. Having a self-driving car is not fun. So it's kind of like figuring out from that very explorative and curious mindset, like how we make sense of AI, how we use AI. And I think they have a lot of insights that could inspire adults.
Yeah, and you and others have also noted that actually a lot of the users of AI are Gen Z, yet most tools aren't really designed with them in mind. So, what do you think is the biggest disconnect between how we currently build AI and how many of these young people want to use it?
The biggest disconnect is that we don't have a knob for agency to control how much we delegate to the tools and how much we take like control or stay in the driving seat. So most Gen Z use off-the-shelf generative AI products like ChatGPT, Gemini, Claude. And these tools like have this baked-in assumption in their design that they need to do the work for you instead of maybe asking you questions so you figure out how to do the work, or brainstorming, or kind of like collaborating. So I like a much more Socratic approach. I very much believe in the Socratic learning and learning by doing. And I think like a big part of learning is asking and being asked good questions. So a huge role I see for generate AI for in the future for learning and for new generation is use it as a tool that can teach you things, ask you questions, kind of show you the blind spots, brainstorm with, but not a tool that you just delegate the work to. And you know, like we're seeing now a disconnect because obviously young people are using AI all the time, and then like in schools, like there are all these kind of lack of trust and loss of trust of like, you know, teachers complain about cheating, and while the teachers themselves use generative AI, right? So there's like kind of this big elephant in the room where we don't have like clear guidelines and kind of a good conversation around what are best practices for how and when and if we should use AI. And also that the tools are not always designed for that, right?
So you mentioned the Socratic approach. So how do you technically implement Socratic approach in this I guess, in this world of text interfaces?
Yeah, I will give you several examples, and they're not all on text interfaces because I'm building multimodal AI apps. So the first example in Cognimates, which is this block programming language on top of Scratch, I created a Copilot. It's the first Copilot for kids coding, to my knowledge, and this Copilot is not coding, is not doing the code for the kids. This Copilot is actually asking them questions. So if, to give you an example, if a child says like, okay, like, how do I make the dude move? This is verbatim a quote from one of the questions they would ask the Copilot, right? Referring to a character in their game on the screen. And then the Copilot would be like, oh, which way do you want it to move? Or like, how do you want to like break down like the motion event, right? Or so it's asking them questions instead of saying like, put this block and there, or like use this block and then that block, like just giving them the solution. So it's asking them questions. If they're really stuck, like if they're asking the same question more than 3 times, then it's gonna start kind of leading them or giving them insights towards the solution. But the main goal is to ask them question, or if the kids like paste an image of the code blocks, to explain to them how it works. Generate images for their games, but like we put a lot of work into how the filters and the styles and kind of like how these images fit the Scratch programming model and kids games. And they can talk to it too. They don't need to type, right? So and when I was designing this, like it actually started with research. So I've done several studies in the past 3 years to figure out how to build this Copilot for kids with young people from 11 countries. So not only English speaking, not only North America, like I'm from Romania, like, and I speak 7 languages. So I work with young people from all over the world. And before building the tool, like the approach was to do a Wizard of Oz, like faking the Copilot, having a person behind the scenes who's pretending to be the AI, just so we figure out what the kids want, what questions they ask, and like what are the most important use cases. Then we went and built it, and we realized like, oh, kids really want like a pair or like a system that can help them clarify their thinking, because a lot of programming and game building is around computational thinking. So how do you break down a complex event into like steps that are the good computational units, and that was one thing, like help them kind of understand like how to break down their complex ideas for games into smaller steps that they can actually implement by asking questions. Another one was when they were stuck, like to help them with debugging. And the third one, and this actually surprised me, but it was really prevalent in the data, was affirmations. So whenever they do something that is fun or cool, like the Copilot says like, that's awesome, I like that effect, and like what if you add the sound. And we've seen, like, and the parents told us as well, like the kids attending in our longitudinal study would spend double the amount of time coding because they had this infinitely patient Copilot that would like ask them questions, help them debug, and then give them like affirmations that reinforce their creative identity when they did something. So with those kind of clear design directions, I went and built the tool. And then, of course, after building the tool, evaluated it again, tested it with kids. And I'm presenting a paper at ACM IDC conference, Interaction Design for Children, in 2 weeks. And it's online, so I definitely we can include the link to the paper. It's on my website as well, that presents this work in more detail. But yeah, I think this example is something that I would hope it gets replicated. Like I work primarily with middle schoolers, but in general in education, to co-design with your users. And like, because these interactions and interfaces and user flows are evolving very fast, like I think it's very important to understand what young people today want and how they work and how they think, and kind of design with them, not only for them.
Yeah, it's interesting the way you describe it because the typical developer or knowledge worker now, when they interact with these things, in some ways they over specified the prompt, right? Because basically they describe so precisely, because they've probably interacted with the LLM before and they've gotten it into their head that you've got to specify as much as possible in order
Right.
for you to get the right result. But what you're describing is kind of interesting because basically you're building what you're building incrementally, but somehow we've gotten away from that as grown-ups, huh? The way we prompt.
It's all about tinkerability and having like the right level of abstraction. Like what are kind of like the Lego blocks that we operate with. And if they're too abstract, like I think sometimes like a prompt, is just not tinkerable enough. Like you're giving this blob of text and then you get the final output. And then maybe you try to refine or edit, but it doesn't allow for enough expressivity and kind of tinkerability to be like, oh, I'm just going to build, let's say I'm generating an image like the background and then like the outfit and then like that. So it needs to be composable and also allow the user to kind of be in control in the driving seat in the creative process or in the learning process. I mentioned that I don't only work with text, and I think right now, like the part that is very exciting for me is multimodal and things that can work on a phone, right? Because a lot of us and young people and spend a lot of time on their phones, and it's also more accessible worldwide. And we do have open source models that are multimodal and can run on device. So you don't even need to send your data to the cloud. Like today, the cloud was down, right? Like you wouldn't have a problem. The model runs on your phone. It can parse images, it can parse videos, it can parse sensor data, text, and then it can also produce like all of these modalities, not only text. And I worked on recently on two projects that are multimodal and mobile first. First one is around math, because math is a domain where we've seen the biggest learning losses during the pandemic, and it's also one of the reasons why so many people kind of drop out of STEM after middle school. And in math, like in algebra, together with collaborators, Nancy Otero, like we created a benchmark first of misconceptions. Like what are all the possible mistakes the middle schoolers can make when they learn algebra? Like not understanding the order of operations, not understanding negative numbers or the equal sign, like you could move elements from one side to another of the equal side. And this is like based on prior work and a lot of research that was done on algebra learning. So we created a benchmark, 55 misconceptions, and then we tested to see if multimodal LLMs can pick up a misconception based on pictures of kids' exercises of math, right? Handwritten on paper. And found that and then like we got the results, ran the results by teachers, like experts, to say, do you agree? Do you agree with this? Labeling? Do you agree that these examples are this type of misconception? And kind of confirm that teachers agree with all of the labeling that done by the models for these misconceptions. And then I built an app that in real time, you can use a webcam or your phone. You're solving math on paper. It's called MathMind. And as you're solving math, it's going to ask you questions. It's like, oh, what do you think happens if you divide this by 5? Or like, what happens if you multiply it? Or what? And then if it detects a misconception, it detects that you don't understand the core concept, it's going to propose additional exercises so you get to practice that concept. And I think that's extremely powerful because there are lots of cognitive science papers that show that we retain and learn much better working on paper. So I think it makes a lot of sense to solve math on paper. But then having this tool that can ask you questions and in real time detect, like, it's not about getting the right answer, or it's about like understanding the concepts, because like all of these concepts like build on each other, right? So there's this zone of proximal development from pedagogy. So if you miss a core concept, it's very hard like to keep on building. And for teacher is useful as well at the beginning of a class to say like, okay, like I just want to see from my class as they're solving how many people did not understand this concept before I move on, right? That's an example of a tool that is not only text, and I think it can be very powerful. And I guess the insight there is creating this domain specific benchmarks and working in my case with math teachers and really kind of with domain experts to understand what's the most valuable way to evaluate a tool for this domain, right?
So, who are building these open weights models that you're using as your kind of starting point?
Yeah, so I used a lot of the Gemma
Oh
3N.
yeah,
It's
Gemma.
like
Yep.
Gemma is these are the open source series of models from Google. This is not because I work there as a research scientist, like
No,
they're really
Gemma is
good.
actually quite good. Yeah.
Yeah, they're really good models.
Yeah.
And then I think the latest like model, like the 3N, it's not only it's multimodal, but it's multilingual. So it works very well in multiple languages. And it's small enough that it's easy to run on a phone or on a laptop. So that's pretty cool. Llama, of course, has good models that are small. Mistral is another good one. I think this would be a kind of like the top ones that I've been using.
And the latency. So we're talking milliseconds, not seconds. And also, what about battery consumption?
I haven't done extensive tests for battery consumption, so I don't have the final results for that. But I haven't seen anything egregious. Like it's just like any other app, basically, so far.
Yeah, interesting. So Matt actually is kind of the perfect test bed in many ways, right? Because basically, there's a right and wrong answer in many ways.
Exactly, and it's the future of application multimodal AI and just AI in general. It's going to be neuro-symbolic. What that means is that there's a part that the LLM does, right? Like the LLMs are very good at fuzzy logic. Like we ask, like, how can I move the dude? And it figures out what we mean. But then there's a formal system part, which is actually having concrete specifications and ways to verify them. And math is perfect for that, right? Because we know what the ground truth is. And then the challenge is like, how do we create formal specification in other domains? And I can give you some other examples that are not math and how I went about doing that. But the most promising results right now at the cutting edge of AI are coming from this intersection of formal methods, like program synthesis and large language models. So one example is the alpha geometry from DeepMind, where they won Olympic math kind of competitions, is because they were using like this grammar for describing all geometric rules to constrain the space of searches of like what are possible solutions to geometric problems, right? And that grammar was developed by a researcher. It took him 3 years. So it takes time. It takes time to fully formalize a domain, but it's
So,
what we need.
for our listeners and myself who actually are not paying that close attention to the use of these tools in education, can you give us a sense for the size of the community working on these things? The same sort of solutions that you're working on? Is it mostly academics? Are there startups, or are there research grants? So, what is the level of support for this work?
It's a great question. I'm trying to figure out what's the most diplomatic way to answer it. So the first community that started when I started working on AI education in 2014, 2015, 2014. When I said AI education, everyone was like, oh, you mean like use AI to teach kids? And I was like, no, no, no. teach kids how AI works, right? So it was very early stages. And I think in 2016, we had the first community called gathering of people interested in this space called AI for K-12. So there's a website and a mailing list and a very active community of researchers, educators, like startups, ed tech startups. And yeah, I think AI for K12.org is a great place to kind of see what other people are working on. And it's a good community. It was supported by NSF, and yeah, it's pretty diverse, and there's people from all over the world that joined. But it's still pretty niche. Like it's not a huge community. And then there's this learning and tools community from Schmidt Futures. Like, so Eric Schmidt Foundation funded a lot of initiatives and projects in this space, in particular focusing on math learning, like last year. So that's another community. Renaissance Philanthropy, Kumar, Karg, and Tom Khalil also fund a lot of initiatives in this space and kind of
What about the
push.
Khan Academy?
Yeah, so Khan Academy is part of the learning tools, and yeah, Khan Academy, Khanmigo are a great example. There's some issues. I actually worked on with their team, the Khanmigo team, during my postdoc, together with Angela Duckworth, who wrote Grit, and other people. So they brought in like developmental psychology expert like Angela, and then behavioral economist, like was my Sendil Mulanaitan, was like my postdoc advisor, and like AI researchers like myself. And it was interesting because they wanted to do like Khanmigo to be all about kind of intrinsic motivation and really understanding like how do you give positive encouragement to the kids. But what I discovered at the time, and this is like a year and a half ago, right? So things have most certainly evolved, is that the math was wrong. So it's all fun to work on positive encouragement and, growth mindset, but the math needs to be correct, right? So the basics need to be covered. And because they were relying primarily on OpenAI and GPT models, they we know the large language models didn't used to be very good at math. Now, they're better, but not perfect, right? Because they're trained primarily on text. And yeah, I think that was a challenge. And I did meet and talk to the person who runs their AI lab and be like, hey, do you guys have evaluations? Like, how do you test if the math is always correct? Because if the math is wrong, 20% of the time, that's a really big deal, especially when you're learning the foundations. And yeah, I think their tool is Socratic, and they definitely kind of share this approach of like teaching by asking questions and like giving a lot of agency to the students. But yeah, it's for me, it was an early example of why it matters so much to have evaluations and benchmark that are education specific, right?
So my PhD is actually in math, so I kind of pay attention to what the research mathematicians are doing in this space, and I'm increasingly reading that they're getting more and more impressed about the capability of some of these leading edge foundation models. But my question to you is, let's say, for example, a month from now, one of these foundation models gets really good at that advanced mathematics, right? So how quickly before you can distill a small model so that you benefit on the phone?
So there was a project, the Minerva, that was like LLM specifically for math, and people who put a lot of effort and time into it. And then like the Alpha Evolve architecture that I described, alpha geometry, sorry, architecture that I described, right? And that's more on the geometry side. I think like a really good model that is always correct at math is not going to be a transformer under the hood. So not like your classic LLM. It's going to be a combination of transformer that does the next token prediction, which works very well in text, together with maybe tool use. So you're always like transforming the math problem in Python code, and you execute it, and then you see if it compiles or not, right? Like, or if
Or
it's
some, in the case of those research mathematicians, there might be using one of these automatic theorem provers, right?
lean form, lean,
Yeah,
like,
yeah.
exactly. So we need to have a piece of the system that is verifiable, and this is like, and I do think like we are there, like we do have those working solutions. How quickly do we make it work on a phone, and how fast? Like, it's totally doable right now. Like, we don't need to wait. And the APIs, like, if we, I mean, of course, you can distill a model. There's open source system like Unslot, which is this young, super young researcher, Daniel Han from Australia, who's single-handedly kind of created this community where it's like, as soon as there's a model, they distill it and make it, available. And it goes very fast. But yeah, I think even if you don't want to use the local models and use APIs, like the APIs are becoming more and more affordable, and there's like wide range of options for people to kind of pick and choose from. So we can build those tools right now and make them run fast and reliable on edge devices.
So, human in the loop in the case of education means parents in the loop, right?
Depends some,
So
yeah.
what extra steps do you have to do in order to be comfortable that your whatever you build is ready to be deployed and be scrutinized by tiger moms and tiger dads?
I speak at a lot of conferences, and the most kind of common question that I get is, I have a kid, what should I do with my child, right? Like, and I was getting this question so often. So I sat down and I wrote a very long handbook for parents, and kind of like a support for, if you want to like talk to your kids about AI, or if you want to know like what's the landscape of AI education, AI tools, and everything you should know for your family, like here's a breakdown, right? And I'll, again, we can hopefully add the link to that in the podcast. But it's something I researched for a long time, because during the pandemic, I worked with the same community of families, like 20 families from 10 different states in US. But 2.5 years, like I worked with them, right? So I saw their kids growing up. I saw how the parents were mediating use of AI in the house, or how they would learn different AI concepts together with their kids, like how to take apart voice assistants, or how they would design their own voice assistant, right? Or how they learn through games how machine learning works, and recommendation system, and about bias and how to solve bias, or like kind of. So I think there's a lot of like work to be done for families, and parents are very overwhelmed, and I understand, right? Like, I'm overwhelmed as a researcher in AI, because things are moving so fast. I can only imagine as a busy parent, like to having to keep track of, like, from smart toys that collect data from your kid, to all the apps, to the things that are being used at school, college application, like, and there's like this constant fear of like not wanting your child to be left behind, but then also not wanting them to be on devices all the time, which is extremely valid, right? So the answer there, I mean, I don't have like the final answer, but like I think it's important to make a plan, and it could be very simple, just to have conversations. It could be like a dinner conversation with your child of, how are you using AI, or like what do you think about AI, or like how do you think it's going to change, like, what you're going to study for college, or what you do after college, or, and coming from a place of curiosity, right? Like, not necessarily from a place of telling them what to do, but opening the conversation. I think that that's very important. Connecting with other parents, and kind of trying to share best practices and learn best practices. But it's a lot. It's a lot to navigate.
So let's close with UX. So we talked about kind of implementing the Socratic method, right? So, but one of the things that people are talking about now, granted, it's more science fiction at this point than reality, is multi agents, right? So I guess at some point, some kid will be using some tool where they're orchestrating a bunch of agents somehow,
Yeah,
right?
yeah.
So what kinds of innovations in UX are you seeing in order to prepare us for this world, or are lacking, or do you collaborate with UX people?
Yes, yes. So let me break it. So there are multiple questions in there. Thanks.
Yeah.
Like so, the multi agent part is very interesting because when I was doing this study on the Scratch Copilot, many of the kids at the end we had a design session with kids, which was like, how do you imagine this being in the future? What features do you want? How would you like to use it with like friends and family? And this theme of agents, multiple agents emerged, right? So many of them wanted that, and they wanted to be able to run simulations. So you have one copilot where you kind of, let's say you want to do Pac-Man, and you tell it, make the maze in this way. You have another copilot, you give it slightly different instructions, and then you're programming part of it, but then you can see how all these like 5 different agents in parallel are programming Pac-Man slightly different and learn from what they do. So this is something they already expressed the desire to have. And we talked about Scratch community, because the reason Scratch is so big is not because it's block programming, but because it's social learning, because it's a community where kids share their projects and remix each other's projects. So I asked them in the future, like, what happens if some of these games are done by agents, and how would you like to know that? And like, if you make a game with an agent, how would you like to share that with other people, right? And so we talked a lot about that, and it's definitely something that they want, and it's definitely something they want to be very transparent about, to say like, this is 50% done with AI, 70% done with AI, or this is 100% done by an agent, right? And kind of having a hybrid online community where it's like agents and kids and agents and like everything in between. And it's not science fiction. The technology for this already exists. So I am collaborating like with the folks from this is Alphamorphs, is a startup based in San Francisco, and they created a technology called InfiniBranch, which is basically allowing you to create a lot of virtual machines, virtual environments, where you can test agents and see agents in action. So the idea for them was, with this new crop of operator, like OpenAI launch operator, that can take tasks, it can take actions on the web and kind of book a flight for you, or search for things, add things to your calendar. Google launched Project Mariner. So in the future, like we're clearly going to have agents that take actions, right? And how do we evaluate them? How do we observe them? So Alphamorphs created this technology where you can deploy hundreds of these agents and observe them. And I told them about what kids wanted in, Cognimates, and they were like, totally, like let's make it happen, right? So it's not science fiction. It's something that we can test and implement now. It's definitely going to be like kind of this era of simulations and tools for thought. Like I think it's like one of the most exciting areas, because it means we parallelize exploration and learning. Like we don't need to do, now we do this experiment and then we do that experiment. You could run 10 experiments all at once, or 100. And yeah, pretty excited about that part.
Yeah, I guess to qualify what I meant by science fiction, I meant in the enterprise, because a lot of enterprise people get ahead of themselves, right? So let's get one agent working well first
Correct. Yeah, yeah,
we
yeah.
aim to have a bunch of agents talking with each other and coordinating, right? So, and I think a lot of the vendors, frankly, are are getting ahead of themselves in terms of marketing.
Absolutely. Like it's one thing to do a demo and kind of show the proof of concept for a technology. It's another thing to get it to work 100% reliable.
Yeah. And with that, thank you, Stefania.
Yeah. Thank you so much for having me.